Assalamu alaikum and greetings. Today we'll discuss heat exchangers. This is very important video. Starting from this video, I'll inshallah be uploading various videos regarding the technical aspects of various industrial equipments. So in this lecture, you'll learn about heat exchangers, the thermodynamics of heat exchangers, and the basic principles that how a heat exchanger works and what principles it acts upon. Further, three below topics will be explained in the coming videos because this will take a longer time as this is a technical video, so it takes longer time. A heat exchanger is any device that is used to cool or heat fluids. It uses a medium, a solid medium, to divide different fluids that are to be heated or cooled. If there is a medium, then we call it direct heat exchangers, and if there is no medium, then there are indirect heat exchangers. The fluids are either gases or liquids that are heated or cooled. Heat exchanger has various applications throughout industries. If you talk about any industry, you will see a heat exchanger there. So there are a number of ways to classify any heat exchanger based on the flow type, components, and construction way used. And also the mechanism of heat transfer also plays an important role in classification of heat exchangers. Heat exchanger thermodynamics involves that the study of heat energy, temperature, and relationship. As we know, this is what thermodynamics is. So any heat exchanger is typically working on the principles of thermodynamics. To understand the working and design characteristics of a heat exchanger, we must understand the basic principles of thermodynamics. This includes the basics of thermodynamics, which are basics of heat transfer. We call them conduction, convection, and radiation heat transfer processes. Starting from conduction heat transfer. Conduction heat transfer is the thermal energy transfer from a material to another material which are in contact with each other. Mostly thermal conduction involves a solid material, and then there may be a liquid or gas material involved. Conduction process mostly involves the heat. When a substance is heated, then the average kinetic energy of the molecules of that material are increased. When the thermal kinetic energy is increased, then there is an increase in temperature. So to transfer heat, there must be a shift in the equilibrium point. If there is an equilibrium, there will not be any transfer taking place. So in order to have heat transfer taking place, we must have two various materials having a difference in temperature. So one will be hotter one, which has a higher average kinetic energy, and then there will be a cooler substance which has lower kinetic energy average. So the heat transfer takes place as long as there is difference between the cooler and hotter objects equilibrium point. When equilibrium is reached, then there will not be any transfer taking place any further. So the Fourier law of heat conduction is used to describe the thermal conduction, which is given as Q upon T is equal to K into A into delta T upon D. Here Q is the heat transfer rate per time T, and K is the thermal conductivity, which is dependent on the material properties, intrinsic properties. A is the thermal area where heat transfer takes place, and delta T is the temperature difference of hot and cool substance, and D is the thickness of the material. Convection heat transfer. This transfer is the transfer of heat when a fluid transfers heat from the surface whenever it is heated. So when a substance like a fluid, whether it is gas or liquid, is heated, for example, it is air or water, then the particles move further and get high motion. So when there is high motion, then there is high temperature. So the higher temperature substance surface rises up to the cooler substances, and there is a transfer of heat taking place. This transfer usually takes place when two fluids are involved. There is no solid involvement in convection heat transfer. What happens when a fluid is heated? It becomes less dense, which rises up related to the cooler fluid parts. Hotter substance or material or fluid is lighter than the cooler one. This point must be remembered. So air that is heated, it will rise up, and air that is cooled, it will go down to the bottom. For example, the example is very clear. When air in the room is heated, the hot air rises up to the ceiling, and the hot particles are replaced by the cooler ones in the room, because warmer air is lighter than the cooler air. Now, the Newton's law of cooling describes the convection process mathematically as Q is equal to Hc A delta T. Hc is the heat transfer coefficient for convection heat transfer. A is the thermal area, delta T is the temperature difference, and Q dash is the heat transfer rate. Radiation heat transfer is the mechanism of heat transfer which involves the emission of electromagnetic waves. Electromagnetic waves are released whenever a substance is at least temperature of absolute zero, which is minus 273 degrees centigrade. When electromagnetic waves are emitted, then the radiation heat transfer takes place from those emissions. This transfer requires no medium, unlike other two heating processes, namely convection and conduction. So it does not need any medium. That is why we receive heat energy from sunlight is in the form of radiation. Stefan Boltzmann law mathematically explains the relationship of radiation heat transfer. It says Q is equal to epsilon sigma into TH minus TC power 44 whole into AH. Emissivity is epsilon, which is between 0 and 1 if we talk about lighter substance, lighter material or darker. Sigma is the constant for radiation heat transfer, which has a value 5.67 into 10 power minus 8. And T temperature differences are between hot and cool body, and A is the heat transfer area. Now, the basic principles that are used to understand heat exchangers. All the heat exchangers, regardless of their type and design, have similar basic principles. These basic principles are actually belong to thermodynamics. Any heat exchanger is based on these laws. From zeroth law to first and then second law, these are the principles that run or operate a heat exchanger. Zeroth law says that when two systems are in thermal equilibrium with a third system, then it means that those two systems are in equilibrium with each other. It says that temperature is a measurable property, which is the measurement of average kinetic energy of molecules of a material. This law says or defines thermal equilibrium as a transitive property. The first law of thermodynamics. This law is based on the zeroth law, and it defines internal energy as another thermodynamic property. Internal energy is the energy inside a body or material. When it is in motion, then it is called kinetic energy, and when it is static, then it is called potential energy. Internal energy depends on temperature, so it only changes when the temperature of the material is changed. This law indicates the influence of heat and work on systems' internal energy and the surrounding energy. So this law also describes energy. It is also called the conservation of energy law, which means that energy cannot be created nor be destroyed. It can only be transformed from one form to another form, like heat into work or into some other form of energy. So the second form of first law of thermodynamics is that whenever a system gains energy, then there is a loss of energy from the environment. Now, few things must be remembered: that work is positive when work is done by the system, and when work is done on the system, it is negative. Similarly, when energy is added to the system, it's positive, and when energy is lost from the system, it is negative. Law describes another thermodynamic property called entropy. Entropy is the disorder of a system. It either increases or stays there, but never decreases. Mathematically, entropy is equal to delta Q upon T, where T is in absolute temperature and delta Q is the change in heat energy. There are two statements. Kelvin's statement says that we cannot use complete amount of energy from a source and convert it 100% to work. There must be a waste of energy. So 100% efficiency is never possible. Secondly, Planck says that whenever heat flows, it flows from hot to cold. It cannot flow from cold to hot, but if an external source is involved, like we see in refrigerator, electricity is involved as an external source. Lecture ends here because of various technical aspects of these topics. We'll see you next time in the second part of this video. And stay united, chemical engineers. Support, like this channel, share this channel, and subscribe. Click on the bell icon to get the next video notification. Thank you for coming.